Yeah. That's what microphones
What's
do.
up, Linsmeyer?
Exactly. You don't even have to speak that loud, and they can still hear you.
Hi, myself, or is anybody watching this video?
On the interwebs.
You are so lucky you're not in the class right now.
Yes! Alright, so before we get to the good stuff, a must that I've got to remind you because the boss lady told me I had to, and then she went home. You have 4 videos that you need to watch prior to your Tuesday class. Okay? They are active on It's Learning right now, so if you wanted to watch them tonight, that's fine. I would budget about 2 hours to watch the videos combined.
Totally lying.
No, I'm totally not lying. Each video is about a half hour long. Yeah. Okay? And if you want to be not confused about Tuesday's class, then you want to watch the videos before Tuesday. If you like being in a state of confusion, then don't watch the videos. What?
Are they actually 2 hours?
Each one is 2 hours, yes.
No, like, is it actually going to take 2 hours?
Well, it depends on how many times you have to watch it to make sure you take the notes on it. Okay? I think each video is between 4 and 6 minutes long. So.
Oh,
yeah.
so not how many videos are there?
4.
Okay, so only 30 minutes.
So it's less than that. And you got 5 days to do it.
You definitely scared me there. I was like, you mean I gotta set aside 2 hours?
While you're eating Buffalo Wild Wings, you could be watching
While I'm
videos.
eating Buffalo Wild Wings, I'll be doing my econ videos.
Each video is a problem, so we basically took what we were going to do in class. If we would have had a class between Friday and Tuesday, we took those videos that we wanted to do in that class, and we made it a video out of each one of those examples. So yeah, each video is like, I think the longest video is 7 minutes because I went off on a tangent. Yeah. So yeah. And then don't forget your cone labs are also due tomorrow. Okay. So most of you turned those in yesterday. All right. So 2 good warm-up problems for you today. So yeah, let's warm it up, Chris. About 2.
Pick a second color, Brenna.
Warm it up, Chris.
I used pink yesterday. Use pink and dark blue.
First thing gots to do, common denominator.
Oh my god, I forgot we would do that. That's why I couldn't get it.
So the first one, adjust to, what would that be, 1 minus the sine of x. Second one, adjust to 1 plus the sine of x. Combine numerators. Denominator, do we want to leave it or do we want to multiply it? How about multiply it?
Wait, what? Okay, why can't you just leave it because they're like pieced together and X and Y?
But why can't I just go like that?
But why can you not? So what I'm trying to do, I guess, wouldn't work then because
Nope.
wouldn't.
I mean,
Yeah, but
I could think about it a little longer, but
I know, but I want to know why. Because normally I do it on a test and I don't know why.
where's what and what?
Oh.
Numerator simplifies to 2, right?
I'm so confused.
Right?
Because the signs cancel out.
Because the signs cancel out, and 1 plus 1 is 2. I get 2 secant squared of x. 1 over cosine is secant.
So having the 2 on top just makes it 2 secants?
Yep.
Okay.
Talk to me, Gordon.
Where did secant come from?
Because it's 1 over cosine squared.
Oh. What? Okay. Okay.
So 1 over cosine is secant, right?
I guess.
Learned that first day of unit circle.
Oh yeah. Okay. Yeah.
Okay, right. I'm like, this is like 3 months ago we've been using that. Okay.
Yep. Makes sense.
All right.
I know you're not. I can't like. Huh?
Secant squared is tangent squared plus 1.
So basically, you're just simplifying terms. You're not even. You're solving, but simplifying.
I'm not solving because there's no equal sign.
Oh, so you're simplifying.
Or just simplifying.
Okay. Anybody else kind of confused right now? Doesn't secant? Right now, I'm kind of just copying that one. Yeah, me too. I think if I copy it more, it'll help me understand.
You know, if you say something more than once, you're more likely to. That's why teachers are so smart, because they teach the same thing.
That's debatable.
Present company included.
What?
What's up, Logan?
I get that problem, but for 13, how does it simplify to a 1 minus sine squared x? Like the denominator. Do you get what I'm asking?
That's what my question was, and I got totally disregarded.
Totally disregarded.
I did. I was actually
Totes.
you're like, that's wrong.
Can I go
I was like, why? And you're like,
like that, just so I don't have to write sine every time? Call y sine of x.
yeah, just picture y
With me?
and signs in it. So instead of writing y, 1 minus sign, he just wanted to write y. So
Oh,
just,
yeah, I get that.
Now continue.
Right?
Yeah.
Okay. Okay.
Oh, you distributed.
1 plus y minus y minus y squared.
All good.
Good on both of those?
So even if it doesn't have like a denominator, you still could give it one?
Well, because this one had a denominator, so if I'm going to combine them, yeah,
Okay.
I have to get common denominators. Yep. 1/3 plus 1, I got to get common denominators to add those two together.
Okay.
Bless you. I haven't done anything yet.
I did not.
learned about that the same day that we learned that 1 over cosine was secant. Not even paying attention.
Can you just not make us feel more dumb today?
No, I'm not. I'm picking on Cordy.
I thought you were picking on me.
No,
Hey now.
picking on Cordy.
Hey, Cordy, way to share the wall. It was just a simple.
I know. So now what?
Cross out the.
Now we gotta get common denominators. It's addition.
Yeah, I know it's taking me a while.
Yes?
Yeah.
Numerator becomes
Cosine square. And that's the hammer, right?
so that's
The hammer.
so that's
1.
1. Chance to redeem yourself, Cordy.
Secant.
Woo!
She's so excited.
Good?
Yes.
What does it mean to be complementary angles?
The same angle, but one's positive and one.
Nope.
Equal to 90.
What do you mean equals 90?
Two angles equal 90 degrees.
Those would be two right angles.
Wait.
They add up to be 90.
That's what
But that's not what you said. You said two angles that are 90 degrees.
I said two angles that equal 90
Yeah, he
degrees.
said you.
Yeah, so that means that each angle equals 90 degrees. You need sum or add in there too. Yeah. Yeah, don't, yeah.
Sip your water.
Yeah, sip your water. Okay? So two angles that add up to 90 degrees. Okay? Algebraically, we can say that as, if I take an angle, call it theta. If I take theta, and I've got to add to it another angle, and then that's going to be 90 degrees. Well, thought-provoking question. What is that other angle always going to be equal to? 90 minus my original angle, right? Yep. So this angle in here is always going to be 90 minus theta.
How come they have a little? Oh, is it degrees?
Degrees.
Oh, okay. I don't know. I've never really labeled it like that before.
Okay. But in trig, we deal with radians. So theta is going to be theta. But now theta is measured in radians. (90 minus theta now becomes pi over 2 minus theta, because pi over 2 is 90 degrees. And that equals pi over 2.
What does this have to do with anything?
Oh, big time stuff. Big time stuff. Yeah? Agree with that? That you should have known for a few years now, since you were a tree. Okay. In geometry.
Oh.
Yeah?
It
Alright.
took everybody a little second to get through
Alright.
what we got there.
What I'd like you to do right now is on a calculator, and it can be any calculator that you choose, I would like you to compare the sine of an angle to the cosine of the complement of that angle. So sine of 20 compared to cosine of 70. Sine of 78 degrees to the cosine of 12 degrees.
What are we doing?
You're comparing those two values. Sine to the cosine of its complement. If you add the angles together, they are 90, yes.
Wait, what? But the numbers are equal.
But what do you mean the numbers aren't equal?
Are
They are equal, yes. So both the sine of 20 degrees and the cosine of 70 degrees is 0.3420 if I round it to 4 decimal places.
Yeah.
The sine of 42 compared to the cosine of 48, they're both 0.6691. And the other one is 0.9272. But in all cases, they're the same. The sine of 1 is equal to the cosine of the complement. That draws us to our pink sheet, which is formulas numbers 12 through 17, or identities 12 through 17, which is basically the middle column of your pink page. What the middle column is saying is the sine of 1 is equal to the cosine of the complement. The tangent of an angle is equal to the cotangent of that angle's complement. The secant of an angle is equal to the cosecant of the complement, and vice versa. Okay? So what that allows us to do is open up to problems that look like this. Now when we go and we simplify, okay, now we have to work all of those. So now we have all of the formulas, or all of the identities, 1 through 17 are active. Okay? So we're active all the way 1 to 17. So if I'm looking at this first sine of negative x, I would utilize identity number 2, and that would become negative sine of x. When I see secant of pi over 2 minus x, I would utilize number 17, and that would become the cosecant of x. Cosecant is 1 over the sine of x. So that simplifies down to negative 1. Questions, comments, concerns? Moments. Good? Try that one. No cheating. Flip the page over. None.
Sign them. But I didn't see you were wrong. I'm just wondering where you're going.
You're making eyelash for me.
You got it.
So if I'm looking at that, then that is tangent is sine of theta over cosine of theta times cosine of theta. So that simplifies itself down to just sine of theta. This one, utilizing, I think it's number 13, is just sine of theta. Sine of theta minus sine of theta plus sine of theta is just sine of theta. goldenrod sheet that I handed out is homework. It is due for everybody. We are not on the 85% rule yet. Okay? We gotta get at least 2 tests in before we can get the 85% rule. As of right now, your next scheduled test will be on Wednesday, the 19th of February. Okay? That's when your next scheduled testing is. Okay?